Yes? Okay, so paper 2, question 1 is about this. I have our formula booklet also. The formula booklet is right there. You don't need to memorize. I think almost everybody got that. So this is the area of a sector, but before you can find the area of a sector, you need to find that angle. So the angle can be found in 2 ways. You can use trigonometry, which means you can do something like this. Just trying to save time. You may have a perpendicular, and this will be theta over 2. So because by what you should know, these two will be equal, so this is 2.5, right? So you can use opposite hypotenuse, sine theta over 2 is equal to 2.5 over 4, something like that. Okay? So that theta over 2 will be half sine of that. So it's 2.5 over 4. You don't have to simplify. No time for that. Then whatever you get for your theta over 2, then your theta will be double that. Okay? So some other people did it another way. Without doing the, right angle stuff. Some people left it the way it is. If this is 4, this will be 4, 0, A, B. And this is what we are looking for, so you can use cosine rule. So some people did that, so I think everybody looks okay here. Then for the area of the shaded region, if you complete the shape, you have a full circle. So the shaded region, what is that shaded region called? What? But the unshaded, including this. If I have this now. What is this called? Speak louder, please. I'm fast. Sector. What about this?
1 minus sector.
Major sector. I'm asking for a name, not a formula, Randy. Minor sector, major sector. That's the distinction between them. Major sector. Okay? So basically, you are looking for the area of the major sector of the circle. So all we have to do is just find the angle of the major sector. You've already found the angle of this one, then you can know the angle of this one, which is 2 pi minus whatever you have done. So with that angle, you can make use of the next formula, which is right here. Area of a sector is half r squared theta. We did that in the radian measurement, isn't it? So you can make use of area is equal to half r squared theta. This time around, your theta is 2 pi minus the answer you got in A. Does that make sense? Questions? Alternatively, you could just find the area of, the triangle, actually the area of the sector, and remove from the area of the circle. Different ways you can do. But you cannot say, what you cannot say is area of a circle minus area of triangle is equal to this. Because then you have omitted this part. Understand? So people did it a different way. I don't think this was a major issue. Now, this question was kind of an issue. On January 1st, Lori invests $P into an account that pays a nominal annual interest. Now, what does nominal annual interest mean? We talked about that also in our classes. I think it's in topic 1. It's in topic 1. Yes. So we have this formula for compound interest. PV is the present value, N is the number of years, K is the number of compounding periods per year, and R% is the nominal annual rate of interest. Why is it not called annual rate of interest? It means in every period you have R over K %. For instance, if the nominal annual rate of interest is 36%, but you're talking about the period being monthly, What that means is that the compound interest is 3% per month. If the compound interest is 3% per month, then you can say, oh, the nominal annual rate is 36% compounded monthly. Am I making sense? So in this question, so that is why you will see that even though this is R%, it was divided by K. R% is R over 100. But it was divided by K because there are K periods in a year. Just like 12 periods in a year. If there are 12 periods in a year, it means this R% has to be divided by 12. And if we are talking about 5 years, it means 5 times 12 periods altogether. That is why the power is Kn. Understand? So in this case now, you have, it is compounded quarterly. How many quarters do we have in a year? 4. So which means this nominal rate of interest of 5.5% implies that each quarter there will be 5.5 divided by 4%. Does that make sense? So the amount at the end of the year follows a geometric sequence. Show that you find the common ratio. This is trivia. Look, at the end of the first year, if you just maybe use your formula, A1 will be P 1 plus R over 100K divided by, this is the general formula, right? Divided by NK. Is that not? Hello? Okay, so now, this is AN. At the end of the first year, you have P 1 plus R over 100K divided by K. At the end of the second year, you have P 1 plus R over 100K divided by 2K. And if you have been told that all this follows a geometric sequence, the common ratio is definitely A2 divided by A1. And by the time you divide A2 by A1, this will cancel, this will reduce by what? Oh wait, we have the value of K. Why am I putting K there? K is what? Speak. 4. So this is 4. So this is simply times 4. Times 4. This is 2 times 4, which is 8. Am I making sense? So basically, it's going to be 1 plus R over 400. Oh, we have our R also. Yes? Then, raised to power 4. Do you agree? Because this is going to be 8. So 8 minus 4. Indices. Hello? Okay. So this is your rate, and you can simplify that. You have here. Okay, that's your rate. Imagine they hold these 3 marks. Easy stuff. 3 marks, cheap stuff. Okay, so the next one is asking for how long. Laurie makes no further deposit or withdrawal from the account. That condition is very important because you might do financial maths in future, and every year you are depositing. In fact, there's a particular question when I was teaching sequences that I gave you. This person end up keep on depositing P every year, and I asked you to show that the sum of the non-money is equal to something. It's like a long sequence in terms of P. If you remember that question. Anyways, so if this person did not deposit anything further, it means we can assume the sequence just continues this way. How long will it take the money to double? Okay, find the year. Find the year. Not even